In the late summer of 1977, two unmanned spacecraft, Voyager 1 and 2, lifted off from Cape Canaveral atop Titan Centaur rockets. Traveling uninterrupted through interstellar space, the Voyagers will endure forever, long after everything man has ever built has crumbled into dust. In the event the spacecraft encounter alien intelligence, both Voyagers carry a copper phonograph record, a message, celebrating the sights and sounds of Earth.
And friendly wishes.
These unique discs contain photographs of everyday life, as well as voices, offering greetings in 55 languages. There are also animal noises, the music of Beethoven and Chuck Berry, a baby crying, laughter, rain, and a heartbeat. All of the planets in Voyager's path were in perfect alignment, something that occurs only once every 176 years. The spacecraft were in position to visit all four of the outer planets, a grand slam, an interplanetary home run.
We have ignition, and we have liftoff of the Titan Centaur, carrying the first of two Voyager spacecraft to extend man's senses farther into the solar system than ever before.
They were launched in 1977. That's a long time ago. We say 41 years, but it's really two generations ago. You can think of what the technology was. Your smartphone has 200,000 times more memory than what the Voyager spacecraft have. And so it's just exciting that we've been able to get it into interstellar space.
We launched two Voyager spacecraft. They were basically the same, but they were on different paths. Voyager 2 was the one that was chosen to do the grand tour. That is to fly by Jupiter, and then Saturn, and then Uranus, and then Neptune. And then after 1989, we began what is now called the Voyager interstellar mission. We were on a path we hoped to get to reach interstellar space while we still had power on the spacecraft to transmit the data back. And that's what Voyager 1 did in 2012, and that's now what Voyager 2 is starting to do in 2018. The sun creates this huge bubble of plasma, ionized material, goes outward at 1 million miles per hour and creates a bubble. And inside the bubble, most of the material has come from our sun, and the magnetic field has come from our sun. Outside the bubble, most of the material comes from other stars that exploded 5, 10, 15 million years ago. We have an instrument which measures the wind coming from the sun, and we saw that in fact there was no longer any measurable solar wind. We had left the bubble, basically.
The team has been looking forward for this for a long time and really working hard in an engineering sense to make this day happen and to keep the spacecraft with all the instruments on so that they could, all 5 instruments could sense the heliopause crossing and have data for that. What that means is that the Voyager 2 spacecraft is now traveling in interstellar space.
Well, this just contributes to the number of discoveries that Voyager has been making, and this is one we'd hoped we would have the chance to do, and fortunately, the spacecraft were still operating when they reached interstellar space. It's really quite remarkable. Voyager changed our view of the solar system, really. We saw these active volcanic activity on Io, we saw the possibility of ocean on Europa. Just time after time, we were discovering things that we had not really even imagined some years before the Voyager mission. What makes it so exciting is that not only do we confirm what we thought we knew, but even better, it tells us where we didn't know that there was something to be discovered.
The Voyagers, of course, revolutionized the views of the giant planets. Before the Hubble Space Telescope, there were no real telescopes in space that could give us any clear images. You get these blurry telescope images from the ground. And by going there, you would really revolutionize the resolution, the views. You get the backside views. I mean, if you just look at the picture Voyager took from the backside of Saturn, back illuminated, it's just fantastic. It just makes you marvel about the beauty of the cosmos. If you don't go to a planet, you will not really know anything about its magnetic field. And just going there and measuring the magnetic field at the spacecraft, it gives you the information of how the magnetic field inside the planet is oriented, how strong it is, and what the processes are that go on inside this large bubble that is called a magnetosphere. What was hypothesized in the late 1950s, the solar wind that flows out in all directions from the sun it would have to run eventually into the winds from other stars from the surrounding neighborhood. And nobody knew where this boundary was. Nobody knew how far away it was and whether the Voyagers would ever get to it. But yet NASA and JPL decided to fund the Voyagers to explore further into the depths of the outer solar system to look for these boundaries. So beyond the scientific value of what Voyager finds in interstellar space, it is also a boundary to be crossed by humanity itself. Did we ever think that we could leave the solar system, or at least the plasma, the magnetic field of the sun? At the time when Voyager was built, I think that was not really in the cards, but this incredible team has just made it happen to make these probes that were designed for maybe a lifetime of 5 years, to make them survive 40 years and enter this medium that we never thought we would ever encounter. We hope that we get as much data as we can from them, squeeze them as good as we can. But even after that, they're still our cultural messengers because they have golden records on them that have preserved images, sounds, and other information about Earth that was around in the 1970s. And these golden records will be preserved for billions of years, and they could be picked up by future humans or by anything else that might be out there. And since recently extrasolar planets made us less lonely in the universe than we previously thought, maybe that chance has increased.
We had 6 months to make the Voyager record. And it was absolutely a work of love and a sense of a kind of sacred undertaking, because we knew that we were conferring something close to immortality. It was kind of, to us, a Noah's Ark of human culture. In our greetings section, in which we have 59 human languages, some of them are the dead languages of Sumer and other civilizations that no longer can speak for themselves, as well as the greetings from the humpback whales to represent some of the non-human species that are conscious and that we share this planet. This was a spacecraft that was supposed to function for something like a dozen years. Here we are 40 years later, and we're still in touch. And look at the discoveries that both Voyagers have given us.
I think none of us knew when we launched 40 years ago that anything would be working for such a wonderful long journey. We had hoped that we could reach interstellar space, and actually that one spacecraft has already reached interstellar space in that 40 years. Well, the big picture is the Voyager really revealed how diverse all the objects are in the solar system, and how limited our terracentric view of planets and the solar system was. Every time we turned around, we discovered something quite different than we expected, often found things we hadn't even known were there to be discovered. So time after time, Voyager has revealed really the complexity and diversity of the bodies of our own solar system. And of course, today we now know there are many other solar systems around other stars, which are all different than our solar system. It really is a continuation of the great missions of discovery that took place hundreds of years ago, as first circumnavigation of the Earth, for instance. And in fact, even goes back to the mythological journeys, which were journeys of discovery, returning home with something new and unexpected. In the case of Voyager, nothing itself is not returning home. What's returning home are the messages from deep space of what's really out there, not just what we imagine is out there, but what is really out there.
In March of 1979, nearly 2 years after launch, the Voyagers approached Jupiter, the celestial body that so fascinated Earth's first modern astronomer, Galileo. Passing through the boundary where the supersonic solar wind slams into Jupiter's magnetic field, the spacecraft's instruments recorded a strong bow shock. Named after Jove, the supreme god of Roman mythology, Jupiter is an enormous whirling sphere of turbulent gases, big enough to hold over 1,300 Earths. The Voyagers discovered thin rings of dust encircling the planet, tiny grains containing silicon or carbon, like a fine haze of ash and smoke. Jupiter's atmosphere displays a dazzling variety of alternating patterns. cold, light-colored zones dominated by ammonia ice crystals in the higher altitudes, and warmer, dark belts of solid sulfurous particles in the lower altitudes. Voyager's cameras afforded scientists spectacular close-up views of the Great Red Spot, a storm 3 times the diameter of Earth raging in Jupiter's atmosphere. Voyager atmospheric scientist Dr. Andrew Ingersoll.
The Great Red Spot is a counterclockwise rotating storm, sort of like a hurricane, that has persisted for over 3 centuries. We were amazed that this spot could survive in the midst of all this turbulent activity.
With at least 16 known moons, Jupiter could well be considered a mini solar system. The Voyagers flew by the 4 largest, finding Kalisto pockmarked by craters, Ganymed etched by icy parallel grooves, Europa smooth and icy, and Io glowing a cold and sulfurous red-orange. 9 active volcanoes were found on Io, the first observation of live volcanoes beyond Earth and Venus. These geysers were spewing hot, sulfurous gases 100 miles, high enough to hit a passing satellite. Voyager project scientist Dr. Edward Stone.
If I were to pick one discovery to represent the body of discoveries that Voyagers made, I would pick the discovery of the volcanoes on Io. These were totally unexpected and really forced us to reconsider our whole concept of the evolution of small moons which are orbiting in the outer solar system.
Mystifying man since the dawn of history, Saturn bears the name of the mythological god of the harvest, who reigned in the Golden Age. Traveling at more than 55,000 miles per hour, Voyager 1 arrived in November of 1980, only 12 miles off course after an interplanetary journey of more than 1 billion miles. Voyager's instruments found Saturn's atmosphere to be a cold ball of hydrogen and helium gases, racked by huge whirling storms and whipped by winds of up to 1,100 miles per hour. Saturn's magnificent rings, thought to have been the result of collisions between earlier moons and asteroids, consist of thousands of particles, swirling pieces of rock and ice, streaked like the grooves in a phonograph record. Voyager atmospheric scientist Dr. Andrew Ingersoll.
What Voyager discovered was the incredible structure in the rings. Saturn's rings are really composed of countless numbers of particles, ranging from the size of dust and perhaps larger particles the size of houses. These particles are constantly bumping into each other. These grooves are there because the rings are constantly being disturbed by satellites orbiting in with the smaller ring particles themselves.
As the Voyagers swept by, sunlight penetrated, backlighting and brilliantly illuminating the splendor of the rings, like the spokes of a gigantic Catherine wheel. Voyager 1 flew within 2,500 miles of the surface of Saturn's largest moon, Titan. One of only 3 moons in the solar system known to have an atmosphere, Titan may help unlock secrets to the origins of life. Voyager project scientist Dr. Edward Stone.
Certainly one of the more exciting discoveries at Saturn was the atmosphere of Titan. It's an atmosphere which is mainly nitrogen like that here on Earth, but which contains methane, so that the photochemistry going on there today may resemble very strongly that which occurred here on Earth billions of years ago before life evolved.
By swinging around Saturn, after a close-up view of Titan, Voyager 1 was propelled out of the plane of the solar system and is now traveling toward interstellar space. First detected in 1781 by English astronomer Sir William Herschel, Uranus, in Greek mythology, is the name for the heavens. 5 years and almost 1 billion miles after leaving Saturn, Voyager 2 reached Uranus in January of 1986. Like all the other planets, Uranus spins like a top. but tipped over on its side. Strangely tilted and off-center, Uranus's magnetic field extends in a bizarre corkscrew tail millions of miles into space. Its magnetic poles are also wildly askew. Voyager 2 discovered 2 new rings, dark, narrow, thin bands of ice, rock, and dust with particles the size of a fist. Although Voyager 2 discovered 10 new Uranian moons, the most eagerly anticipated event was the close encounter with Miranda, one of the most bizarre moons in our solar system. Close-ups of Miranda revealed a strange and wondrous landscape, including a canyon 12 miles deep. Miranda may have collided with another moon, shattered, and then by the force of its own gravity slowly reassembled itself into this chunk of rock and ice. These digitized photographs are a silent testament to the violent origins of our solar system. Approaching Neptune, after 12 years on the road and another billion miles, Voyager 2 was an exhausted traveler. By August of 1989, Voyager 2 was speeding more than 40,000 miles per hour toward its rendezvous with Neptune, the last stop on its spectacular grand tour of the 4 outer planets. Discovered in 1846, Neptune was named after the mythical Roman god of the sea. The planet appears blue because its methane absorbs most of the red in the spectrum, leaving mostly green and blue. Voyager 2 flew by Neptune only 22 miles off its charted course, and only 1 second off its scheduled flyby time. Skimming only 3,000 miles over the planet's north pole, Voyager found Neptune to be a giant ball of melted rock and ice, cloaked in hydrogen, helium, and methane gases, its atmosphere whipped by winds of up to 700 miles per hour. Voyager flew the closest that any spacecraft has come to one of the outer planets, discovering at least 4 complete rings of ice and rock, 6 new moons, and a great dark spot, a hurricane the size of Earth raging in Neptune's southern hemisphere. Dr. Andrew Ingersoll.
The storm revolves around the planet every 18 hours, and then it rotates around its own axis like a big glob of pizza dough every 16 days.
Largest of Neptune's 8 moons, Triton orbits in an opposite rotation from the planet. Scientists saw jagged mountains, high cliffs, and frozen lakes. The most bizarre discovery on Triton was the presence of icy geysers, some of which are still active, spewing organic particles 100 miles downwind. Dr. Edward Stone.
The Voyager mission to the outer planets has certainly been a journey of a lifetime. Having encountered Triton as the last world we would visit, I don't see how any of the scientists could have been happier.
Voyager 2 has set its course for southwest of the constellation Sagittarius. Traveling at 10 miles per second, it is expected to pass 4 light years from Sirius, the brightest star in the heavens, 290,000 years from now.
On April 28, 2011, NASA held a press conference to reflect on what the Voyager mission has accomplished and to preview what lies ahead as the probes prepare to enter the realm of the Milky Way itself. The Voyager adventure began in the late 1970s and 80s when the probes took a grand tour of the outer planets. Voyager 1 visited Jupiter and Saturn, while Voyager 2 flew past Jupiter, Saturn, Uranus, and Neptune. Voyager 2 is still the only probe to visit Uranus and Neptune. When pressed to name the top discoveries from those encounters, Stone pauses, not for lack of material, but rather an embarrassment of riches. It's so hard to choose, he says. There was the discovery of volcanoes on Jupiter's moon Io, evidence for an underground ocean on Europa, hints of methane rain on Saturn's moon Titan, the crazily tipped magnetic poles of Uranus and Neptune, planetary winds that blow faster and faster with increasing distance from the sun. Each of these discoveries changed the way we thought of other worlds, says Stone. In 1980, Voyager 1 used the gravity of Saturn to fling itself, slingshot style, out of the plane of the solar system. In 1989, Voyager 2 got a similar assist from Neptune. Both probes set sail into the void. Sailing into the void sounds like a quiet time, but the discoveries have continued. Voyager 1 and 2 are now at the edge of the solar system in a place called the heliosheath, where the solar wind meets interstellar gas for the first time. This is a very strange place, filled with a magnetic froth no spacecraft has ever encountered before, echoing with low-frequency radio bursts heard only in the outer reaches of the solar system, so far from home that the sun is a mere pinprick of light. In many ways, the heliosheath is not like our models predicted, says Stone. Soon, in a matter of years, the two probes will leave the solar system altogether and enter the realm of the stars, interstellar space, the Milky Way itself. Then they will have a new job, ambassador. Each probe is famously equipped with a golden record, literally a gold-coated copper phonograph record. It contains more than 100 photographs of Earth, 90 minutes of the world's greatest music, an audio essay entitled Sounds of Earth, featuring everything from burbling mudpots to barking dogs and a roaring Saturn V liftoff, greetings in 60 human languages and one whale language, and the brainwaves of a young woman in love. A team led by Carl Sagan assembled the record as a message to possible extraterrestrial civilizations that might encounter the spacecraft. Some people say that the chance of aliens finding the golden record is fantastically remote. The Voyager probes won't come within a few light years of another star for some 40,000 years. What are the odds of making contact under such circumstances? On the other hand, what are the odds of a race of primates evolving to sentience, developing spaceflight, and sending the sound of barking dogs into the cosmos? Expect the unexpected indeed.
At 70 times further from the sun than the Earth, Voyager 1 is at the very edge of the solar system. The sun there is only 1/5000th as bright as it is here at Earth. For 25 years, the Pioneer 10 spacecraft led the way in pressing the frontiers of our realm of exploration. And in a certain sense, what's happening is the baton is being passed from Pioneer 10 to Voyager 1, which now has to take up pressing this frontier, going where no one has been before. The two spacecraft, Voyager 1 and Pioneer, actually headed almost opposite directions away from the sun. Pioneer 10 is headed down what's called the tail of the heliosphere, the comet-like shaped region that forms around the sun, while Voyager 1 is headed toward the nose of the heliosphere.